So for this, they're asking now for the Lewis structure of what is the Lewis structure of formic acid. So for this, we have to actually know what formic acid is. So with that being said, we actually have this as our structure. Remember the whole structure of isomers. This is something that we can use in terms of like formic acid, just in one structure there. But depending on how we want to write it, there could be other structures we can base this on that would still give us, you know, this formula. It doesn't mean that it's formic acid still. With that being said though, let's actually find out the Lewis structure for it. So first we need to find out how much each element donates. Well, it gives in terms of the total electrons. So hydrogen is typically 1 because it's the first column periodic table. And if you want to actually use electron configuration, in case you're dealing with like transition metals, it'd just be 1s because it's just right there, almost kind of like just starting the beginning of the electron configuration. C, on the other hand, carbon, okay, typically because it's on the 14th column, is going to be 4. You can actually see here that we actually have, when we start with helium, okay, it's going to be 2s2, 2p2. And oxygen, on the other hand, is going to be just 2 more after, so it's going to be same helium, but 2s2, 2p4. And then we have, so we have 2 oxygens, and then we have 2 hydrogens, okay? And with this equation here that I gave for oxygen, you can see that it actually has 2 plus 4, 6. So that is going to be, okay, 1 plus 1, so that's 2 for hydrogens, plus 4, plus 6 times 2, so that's plus 12. And with that being said, that's 12 plus 6, 18 electrons total. So with that being said, we want to be able to visualize what the best connection would be for this. So in regards to that, we start with carbon in the middle since it has the most amount of unshared electrons. That's why we can really fill up the valence shell and many things can attach to it. So we have carbon, an oxygen here, an oxygen there, a hydrogen here, and let me just rephrase that. It's going to be like that for now. And then it's going to be like that. Okay? Now the only thing that's missing now is just to make sure we have this double bond. Okay? And this. There we are. So just quickly review it. I want to make sure that we actually have the 18 electrons, so 2 oxygens. So that we have to really fill this out. And now let's count. 2, 4, 6, 8, 10, 12, 14, 16, 18. So this indeed is the Lewis structure for formic acid. And you can actually double check by getting their formal charges. So with that being said, the formal charge of carbon would be 4 minus, okay? The amount of things it's bonded with, the amount of lone electrons it has is 0. The amount of things it's bonded with is 8. So it's 0 for the next time. Okay. So this is a good formal charge. And now for the oxygens, we have 6. And then how many lone electrons does it have? It has 4. And then plus how many bonds does it share? Each one says that they're sharing 2. So that's 4 electrons total. So that's also 0. So perfect on a row. Now for the hydrogens, it's relatively simple. 1, they had no other lone electron, and the only contact they had was like they only have the lone electron, and the only other contact is just, well, really, that's it. So that's going to be 2 over 2, and that's going to be 0 again. So in terms of formal charge, everything works out for this structure as well. The Lewis structure of formic acid in this form. So let's see here what we're dealing with. Okay, we have the octet rule is satisfied. H only needs 2 electrons, which is correct. Exactly. We have all that. And now for the last thing, well, they didn't do formal charge, but it's always just going to double check, and I was able to do it, and that means that this is correct because the formal charge of all of those were indeed 0. So with that being said, let's move on to question number 13.